Hit mute and then let it.
Hi, we're going to get started in just about 2 minutes, but if you'd like to introduce yourself in the chat, we'd like to know who's here. And if you have experience with either the surface temperature protocol or the mosquito habitat mapper. So please put some information in the chat. We're going to get started in just 1 minute. Before we get started, if you'd like to just introduce yourself and put your name in the chat and whether or not you've had experience with surface temperature mosquito habitat mapper, that'll help Rick and I know who we're talking to. So thanks for that.
Camera is off. Camera is off.
Well, Rick, since you have limited time, I think maybe we should get started. I hope some more people join us. But I would like to introduce my colleague, Rick Sharp. He is a teacher from West Virginia. He has been with Globe for a very long time. And it's really an honor to be co-presenting with him today. And he's going to talk about surface temperature protocol. And then I will follow up talking about mosquito habitat mapper. So Rick, would you like to take it away?
Yes, thank you, Rusty. Welcome to the Globe Surface Temperature and Mosquito Habitat Mapper. As Rusty said, my name is Rick Sharp, and I'm an environmental science teacher at Huntington High School. And I'll be presenting the surface temperature protocol. Well, wait a minute. Sorry, my computer isn't cooperating. Okay, as you know, the atmospheric protocols, surface temperatures come under the sphere of Globe protocols. And as a consequence, this is one that determines a specific site. So with that, I'll begin with the protocol itself with site definition. All surface temperature sites must be defined in the database. And if you're using paper or your data entry app, you'll find that there are 2 sections to this. One is for the site definition itself, where you literally tell where it's located with the latitude, longitude, and the elevation in meters. You also do need to note the source of your location data, whether it's GPS or Google Earth or some other application, and then what type of observations you're going to be taking at that particular surface. The next part of it, of course, is with the location itself, where you actually describe the site. And with that, you want to determine the size of it. Remember that when you select a site, it must be homogeneous. It must be all one particular surface. You can't do a combination. Ideally, they want it 90 by 90 or 30 by 30 meters. But if you can't do that, and many times you can't, they can specify the size, and you can include the information that might impact your observations in the overall data in the comments section or the metadata portion. Sometimes this doesn't let me change, okay? When you take surface temperatures observations, you want to start with our NASA Observer app, the cloud app, because cloud data is a big part of the surface temperature observation. So your first data sheet will show your data that you're collecting. Then the second is on the cloud data itself, and just ask what is the percentage of the sky that's covered, what is the sky colored visibility, and what are the level of the clouds. Also included in this is the surface conditions, whether it's dry ground, snow, ice, or standing water. And you can also, as an option, include air temperature, barometric pressure, and relative humidity. Your observations are taken with an infrared thermometer, and this infrared thermometer must be calibrated once a year using an ice bath, and it must be within plus or minus 2 degrees Celsius to still maintain globe quality data. If you're outside that range, then the only thing you can do is replace your infrared thermometer. When you're taking the data, it must be placed outside for 30 to 60 minutes prior to data collection. And this is to prevent thermal shock and incorrect readings when there's a difference between the temperature of the IRT itself and the air temperature. You can get around this by using an oven mitt, and you'll find that in the surface temperature protocol training section of the Globe website, and you may have already seen that. The observations themselves are taken using the technique shown below. You take 9 separate observations for each particular site, and you do that by holding the arm completely out and pointing the infrared thermometer straight down. You have to be careful about this because it's easy to take a temperature of your shadow or take a temperature of your foot, and these things do influence your surface temperatures. The next thing you want to be sure is that you take 5 or 6 steps between each observation so you cover the entire area. And surface temperatures are an important globe protocol. And as I became involved with them, I began to realize they're much more important and are becoming more important all the time. And this is because of the urban heat island effect, climate change, and the greenhouse effect. Now at Huntington High, we've been doing surface temperatures for about 9 years now. And so we have started using it to look at the urban heat island effect, because as societies become increasingly urbanized, this particular aspect of climate change is going to become more and more important. To do this, we model an urban environment by choosing 5 separate surfaces. This is short grass, and this is, believe it or not, grass of our practice football field. We also use asphalt of our student parking lot, and there would be some metadata that need to be entered here, because you can see, even though these parking lines are relatively small, you still can have an effect on your temperature. So you'd want to mention that in the metadata in case anyone using the data can take that into account. We also have bare earth as an option, and this is the, pardon me, the infield of our softball field, our only bare earth site on campus. It's not the ideal 30 by 30, but it does give us 20 by 20. The next surface is our artificial turf of our football field, and we use this to simulate or emulate the artificial substances and materials that so much construction is now composed of in an urban environment. Incidentally, during the last solar eclipse, we had a 90% total eclipse, and the temperature of our football field changed 12 degrees over the course of the 2 hours that the eclipse lasted. We also take surface temperatures of concrete, and you can see from this that this is not an ideal site by any stretch of the imagination. The site itself is irregular, so we note that, as well as using a picture of it so that any users of the data can understand that it might be affected by the building nearby. We also have a painted surface of our tennis court, and we use that to represent painted surfaces in the urban environment. So the urban heat island effect, the reason we look at it is because it's increasing climate change or speeding up climate change. It warms weather that prolongs exposure to disease-bearing insects like mosquitoes. More and more species are moving further and further into cooler climates, and that does include insects. It also enlarges the habitat for other mosquito species to move as cooler areas warm up. And I think people are starting to note that, and Rusty will note this in her mosquito app, I'm sure. Climate change is occurring because human beings are changing the climatic system. And they're doing this by changing land cover, and they're releasing more pollutants in the air all the time. They're releasing more greenhouse gases, and they're creating the urban heat island effect more because they're increasing the number of urban areas and the size of urban areas. So this is becoming more and more of a factor in our climate change calculations. Some of the causes of the urban heat island effect include absorbent building materials like concrete, brick, asphalt. There's also a tremendous reduction in urban vegetation. It also increases the urban canyon effect. Waste heat goes up, and we know waste heat is any heat that is generated in any process that is used to do work. It's the heat that is wasted that is not part of the work process. And then finally, you can also create thermal plumes as cold air masses actually form above the buildings and traps the warmer heat or the warmer temperatures near the surface. So the reduction in urban vegetation reduces the amount of carbon dioxide taken up by urban plants. And of course, it will also cause the amount of oxygen to be released to go down. It also reduces evapotranspiration and the cooling effect of water. As we know, when water evaporates, energy is going into the air along with the water. And finally, it reduces the cooling effect of shade. More and more of our surface areas are being exposed to direct sunlight. Some of the absorbent building materials we use are asphalt and concrete. And the problem with this is that as it absorbs the infrared radiation, it doesn't just release that in the same wavelength, it releases it in long wavelength infrared radiation. And dark roofs of businesses and residences are part of this, along with just the simple construction materials of streets and buildings and parking lots. These two pictures right here are great indicators of how this process works. If you look at the picture on the left, the dark pavement has an albedo of 10%, meaning only 10% of the energy that strikes that surface is reflected. You can see from the long arrows of visible light coming in through the atmosphere, the small arrow is the percentage that's being reflected. The rest is being absorbed, and of course, later on, that will be released as infrared radiation. For the cooler pavement, which has an albedo of 40%, you can see the same amount of visible light coming through the atmosphere, but you see a larger portion being reflected out, and reflected light passes back through the atmosphere just as the same as it passed in because it's the same wavelength. And of course, the result is a cooler pavement. A good indication of these surfaces in action is the two pictures on the right. The top one is in visible light, and then the low one is in the infrared part of the spectrum. If you look at the infrared picture, you can see that the hottest part of this picture is the street that's covered by asphalt, and of course that's in red, and all of the red areas there, including the buildings over here, are the hottest. So you can see these are all man-made materials. The one that's a little surprising is that the concrete is a bit cooler than the asphalt, but largely probably because of color. But the surprising element is the gravel, the loose gravel over here that's in the area around the fire hydrant, which you can see is blue and is much, much cooler than the other two surfaces. This is because water is allowed to absorb through this gravel, and this water then absorbs into the ground and it later evaporates out. So not only is there water present reducing the temperature, but you also have the cooling effect of evaporation as that occurs. So the best diagram of a simple greenhouse effect and the way surface temperatures and why they're important is in this diagram. You see the amount of visible light coming from the sun. The first thing that happens is in the upper atmosphere, a certain amount of this light is reflected and never ever reaches the Earth's surface. As the process continues, the light continues until it strikes the surface, where some of that light is then reflected. And as you can see, it passes back out into space without affecting our surface temperatures or our climate effect. The absorbed light, however, is represented by the red light. And you can see that the infrared radiation, when it is released or emitted, it gets trapped by greenhouse gases, which warms the atmosphere, which in turn warms the surface of the Earth. And it becomes a process that is increasingly, I guess, getting stronger as we increase the urban heat island effect. So one of the things we can do, impermeable pavement can be replaced with permeable pavement. In other words, pavement that will allow water to soak through and will therefore allow water to evaporate out. Water that on an impermeable surface also tends to run off. And when it runs off, it dries very quickly and of course begins absorbing energy very quickly again. If you use a higher albedo pavement, not just one that's impermeable, but a higher albedo pavement as well, you can see the percentage of visible light striking the surface, and you can see the amount of light that's being reflected back into space. For conventional pavement, you can see there's not as much reflected back, and you can see what is happening is it is absorbed and released. It's being released as infrared radiation. Again, getting trapped and adding to the greenhouse effect. The urban canyon effect is just what it sounds like. It's when cities or house cities are similar to a natural canyon. Streets cut through dense block structures just the way side canyons are cut off at right angles to a main canyon system. So in the surface levels of these systems, temperatures are elevated. Air becomes stagnated. And of course, you get multiple reflections between the buildings that also increases the temperature. So the wind movement is part of this effect. As you can see in the rural area over here, the prevailing winds are coming from the left or from the west. And these stronger winds enhance heat release and evaporation at the surface. And of course, that has a cooling effect. As you approach the urban area, you see that air is forced up, and you see it then starts to circulate between and around the buildings. And this allows upper air masses, cooler air masses to form over the top of it, creating a temperature inversion, which holds the heat at the street level. Multiple reflections are just what they sound like. Remember, every time light is reflected, a certain part of that light is absorbed and a certain part of it is reflected. With tall buildings where you get multiple reflections, by the time all the reflecting is done, so much of the energy is already absorbed that much of the energy stays trapped in the city and continues to contribute to the urban heat island effect. So some of the impacts then of the urban heat island effect is it increases peak energy demand, which doesn't sound like that much, except if we're trying to convert to renewable energy systems do not respond quickly to rapid changes in energy demand. So it makes it more difficult or complicates our efforts to use renewable energy. It also increases air conditioning costs. It increases air pollution and greenhouse gas emissions as a result of the extra power generation by our power plants, many of which are still burning fossil fuels, and even worse, coal. And of course, there's an increase in the heat-related illnesses and mortality. Some of the heat-related illnesses that increase during heat waves, urban heat island effect can actually increase the duration of heat waves. As we're finding out west, this same process occurs with droughts. It increases occurrences of, sorry about that, increased occurrences of heat stroke, heat cramps, and exhaustion results. Mortality rates increase as well. And just in the past couple of weeks, as we've seen the 2021 heat wave in North America, in northwestern North America, that moved across the country and I think is now in the Northeast. But in Oregon, 95 extra deaths were attributed to the heat wave, in which temperatures reached 113 degrees in Portland. Washington State had 78 heat-related deaths, and British Columbia, even further north, had 719 heat-related deaths. And something that we don't think about very much, but because these are coastal areas, there were over 1 billion sea creatures that were killed as a result of this. And it's not just the heat itself that kills these creatures. You have to understand that dissolved oxygen and water content goes down as temperature goes up. So as this water was getting warmer, these sea creatures, they cannot just simply get up and move away, because many of them are mollusks and are filter feeders and are not readily mobile. We're just simply victims of either hypoxia or the extra temperatures. And so with that, I've come to the end. Thank you very much for your time. And I'm going to let Rusty take over and begin with her heat mapping. Do we have any questions or anything you would like to ask me? I've been doing these temperature observations for many years, and I've done a project associated with every one of them, and generally enter them in our globe symposia that we have in the United States. So that it's been something that we've been very active in, and I think is becoming increasingly important.
Rick, that was really a fantastic talk. And you have like one more minute before you have to move, I think. But would you like to just tell us quickly about one of the projects that your students did? Because I think it's great to have a sort of an idea of the ways in which these wonderful GLOBE protocols can be leveraged to do real science.
Well, and you can do it at any level. I happen to be in a high school level. So many of the things you can do with surface temperatures, because I have 6 classes a day and I go out every period, I have this change, as you can see, what happens with the surface temperatures over the day as the day changes. And what I do is I have them compare the different surfaces, and I have students actually come up with the relative albedos of the surfaces. And this is just another way to try to get them to analyze data and to look at data in different ways. We also use this as part of our, believe it or not, our watershed studies, because surface temperatures can have a huge effect on watersheds. And I'm thinking more in terms of the impermeable surfaces. So surface temperatures are one of our simplest observations to take, and I think one of our most important.
Great, thank you so much. That's super great. So we're going to move now to the second part of this talk, which is connecting the mosquito protocol a little bit to surface temperature. And I'm going to share my screen.
Okay.
So let's see here. I'm going to, okay, share. Okay, so now I can't see you guys, but can you see my screen? Can somebody say yes?
Absolutely.
All right, thank you so much. Great. Okay, so I'm moving on, talking about mosquitoes and microclimate, because that's really how mosquitoes connect to surface temperature. And we're going to start by, here's that Earth system. We just talked about how, it wasn't necessarily just the heat that killed all those mollusks and shallow water organisms during that heat wave, but also it was the Earth system connections. And I think, Rick talked about how if you've got, increased temperature, you're going to have less dissolved oxygen. And so they can actually suffer and suffocate. But one thing that we can do, with the Globe Observer app is we have clouds in the atmosphere. We've got trees, which is the vegetation. We've got the Mosquito Habitat Mapper, which is an aquatic protocol, but also a biological protocol, and we have land cover. And so by working with all those together, we're beginning to understand and model what's happening at your study site. So here is Rick's study sites. And I said, you know, a very easy way to begin to model and understand the relationships between these two is to, you know, maybe find your own surface temperature study site where you are teaching or working, and then, you know, build a mosquito trap and put those traps in those areas and see how they are. Now, one of the issues you have is that most mosquitoes are going to look for a shady spot. So you're going to have to find a shady spot near these areas. But nevertheless, this is just a sort of a concrete example of how you can bring together these really interesting protocols. And I never thought of putting surface temperature together with mosquitoes until GIO said, why don't you guys present together? So here we are. So I just wanted to say too, tying back to Rick's really interesting talk, that there is now a lot of research that is happening now where people are looking at mosquitoes in urban landscapes, and specifically at the land cover, the temperature and the surface temperature, because these are the things that our mosquitoes are responding to in our urban environments. A lot of the disease around the world is happening where we have most of our people, which are in the urban areas. That's not to discount the importance of rural areas, but just that it is an area where you might want to begin to look at this relationship between heat islands, surface temperature, standing water, land cover, and mosquitoes. It's a really rich area of research, and there are a lot of really cool papers that you can find. So moving along, people always ask me, you know, why are we doing mosquitoes? If you've heard me talk before, I always include this because this is the question that people always get. Can you see mosquitoes from space? And no, you can't. But what we can see from space through our remotely sensing instruments on our space platforms is the environmental conditions that mosquitoes tend to thrive in. They like warm environments, they like moist environments, they like places where there is land cover, they need to have plants in order to eat, they need to have shade in order to survive in water very often, they need standing water. So NASA scientists can actually use this data to predict where vector-borne disease outbreaks are going to occur, and the data that we collect serves as validation data for these kinds of models. And most importantly, as we're monitoring climate change from space, we're also monitoring the expansion of mosquito populations, both, you know, moving poleward and also altitudinally, because as the world is warming, their range is opening into new areas. Okay, so, you know, our students, globe citizen scientists, they're the ones that are making the connection between the mosquitoes we see on the ground that you can't see from space and what the NASA science sees from space. And we do this because by connecting mosquitoes to land cover. And a new change that we have made in the last year or so with the Mosquito Habitat Mapper is we are asking people to always take a land cover observation every time you make a mosquito habitat observation. This is because we need to understand not only that pool of water where the mosquito is, but is there shade around it? What kind of plants are around there? You know, is this an urban environment? Are there derelict buildings here? Are you in a large lot, you know, in an urban area? Are you in a puddle in Alaska? You know, we need to understand these kinds of contexts. And so we're asking people now to use the land cover app whenever you use the Mosquito Habitat Mapper app. But, you know, what's really cool about Globe Observer and about the Globe program in general is that students get to experience a full data cycle, from collecting data in the field, to uploading the data, to downloading the data, to cleaning the data, then to analyzing the data. And it's really pretty exciting. So mosquitoes make the connection between community and climate change. Around the country, there are, since 1970, there has been dramatic increases in the amount of days where mosquitoes are biting. Reno is one of the extreme ones, 52 more days. Where I am, it's 8 days. Honolulu hasn't changed. There's no change in mosquito days since 1970. But if you go to this website here, from Climate Central, you can actually put in the city which is closest to you and find out how many more days you have which is a proxy for some of the changes that we're seeing because of climate change. And we also have these incredibly new invasive and dangerous species. And around the world, 2 of those are Aedes albopictus, which is the Asian tiger mosquito, Aedes aegypti, which is the yellow fever mosquito, and then those come from Africa and East Asia, respectively. Now Aedes vittatus, which is a mosquito which was found in South America, has just been found in Cuba, and we're anticipating it's going to come to North America. And so these changes are because of globalization and transportation, as well as changes in climate, but particularly once they get here, because our climate is warming, they're able to move northward. So we have a very complex environmental system where mosquitoes are really telling us about climate change. Another reason why I love to teach about mosquitoes to my students is that it helps us understand what's happening in our community. And there is really a big social justice and environmental equity component to this. So if you were here this morning to hear the keynote, this is one way that students can put their own lived experience and the light and the place where they live, their own communities, into their studies, and make a difference in their communities by providing mosquito habitat surveillance and also mitigation, which they also do with the app. Both those things can take place as part of their globe experience. So it has a social justice and environmental equity component. And this has been very, very interesting for a lot of the students I've been working with in the Southeast particularly. So here is just a little bit about the app. And I know that all of you have actually done the e-training, or hopefully you took a look at it before you got here. But it's what we're trying to do is we're trying to understand mosquitoes, and the best way to do that is to connect it with environmental data. It's easier to connect mosquitoes with environmental data from space if we connect it first with environmental data on the ground and then in space. So I hope that makes sense. If land cover provides a little bit of a translation and sort of a hookup, a connection between mosquitoes and our satellite measurements. But basically, it's a very easy protocol in the sense that you're able to do it. All your training is right in the app. You open up the app, and we'll show you the steps in a minute, but basically you find where the source of water is. It might be a puddle in Alaska. It might be a tire in Buenos Aires, but you're going to locate that, photograph it, and then pair it with the land cover, which is nearby. And that is becoming a very rich environmental data set for scientists. Okay, trying to get there we go. Okay. So one of the changes that's taking place in the app is that you're going to begin to see an accuracy bar at the bottom. We have this already for land cover, but we don't have it yet for clouds or for mosquitoes. So this is coming. And what this means is when you open up your app and you get your date and your time, your latitude and your longitude are automatically ported into your device if you have either a web service or satellite data access through your built-in GPS receiver. Your accuracy when you first open it up is 65 meters or greater, and that's not very good. But if you keep pressing that little reset button you see at the bottom there, press that 2 or 3 times, and very quickly you can get to 16 meters or 12 meter accuracy or less. And if you have a brand new Apple phone, which I don't, I heard that you can get up to 3 meters accuracy, but we're looking for 6, 12, even 16 meter accuracy is sufficient for the kind of research that we're doing. So please try and enjoy that new feature that's going to come out when the new app comes out. Here are the steps. So we just did the first step, where and when, then what habitat, and you have a drop-down menu where you choose the menu. Behind each one of these buttons, if it's a container artificial, you hit that and it'll give you a choice. Is it a tire? Is it a flower pot? Is it a piece of garbage that's just laying on the ground? So you have those choices. And then the next thing is they ask you to take a photo of that. And the photos are very, very important. They are a primary part of our data. And we really hope that people will, provide photos for all their observations. And then we ask you to please look at the water. And if you want to, and count how many larvae you see, count how many pupa you see. And if you don't know what larvae and pupa look at, there are pictures right in there for you. If you see little black dots that you think are eggs, you can put that down. If a mosquito is on your nose while you're doing that, you can note that you have mosquitoes, and you can put any comments you want there too. So these things are really, really great. And there are going to be tips on sampling. The way that scientists do this is sample 3 times using a dipper or your turkey baster, your macro pipette, and then you average the 3 numbers. And so that information is going to be a new update on the tips on sampling. But if you don't do that, you don't have to do that. But if you do volumetric sampling, we just ask you to note that in the comments. Then the next thing is that you look at your larvae and tell us what you see. And we ask you to photograph the larva. And there are two places where you photograph the larva in the app. One is looking at the whole body. The second one is looking at the tail end, which is diagnostic for the organisms that we are trying to identify, the ones that are medically important species. And I want to point out that in this app, one of the really good design features that we have that really helps us to maintain that high quality of data that Globe is known for is that you are able to step out at any point. You can just describe the habitat and take a picture, and then you're done. Or if you have the ability to sample, you can go and get some water, count the larva, and then you're done. Or if you want to identify it, you can identify it, and then you're done. And you can photograph the larva, and please do, even if you don't feel like you have time or want to do use the key, because those photographs are really important to scientists. And we're going to talk about that in just a minute. And then finally, and the most important step from a health point of view, is what we call source reduction. And source reduction is when you actually take that habitat that you have found. Let's say it's a tree hole, or let's say it is a flower pot or a tire. And we ask you, are you able to eliminate the breeding site from use by covering the water up with a lid or a screen, or dumping the water out so that it can't be used as a habitat, or removing the trash so it's no longer used as a habitat? Each one of these steps removes the danger of mosquitoes, especially these very dangerous ones, which are invasives that are container species. So this is really important. Of course, if it's a pond, it's a lake, you obviously can't eliminate the breeding habitat, and you just say no. And we'll understand why when we look at the photograph of the habitat. All right, great. So the next one is just to show you that, is it a habitat if no mosquito larvae are present? And this is a question I get a lot. And yes, any standing water that is found on the landscape is a potential habitat, and you can record that habitat and then record 0 larvae, because zeros are important data too. Okay. And these data will help us answer a question that we don't know how to answer yet for your area or other areas. Which of these habitats are most frequently used by these invasive disease vectors that are now being found around the world and have not been studied in these new contexts? So this is very important data that our Globe students are contributing to. So you're almost done now. And the new app that's coming out says, send all the mosquito data now. Only do that. Here's your pro tip. Only do that if you have good wireless. Otherwise, it's in the app. And please upload it once you get back to good cell service or good broadband service. So don't send it if you're in the field and you don't have broadband, because it will kind of go into a loop and it'll prevent you from taking any more measurements. The other thing is then there's a new button saying, please make a land cover observation. So the next thing you do is you open up your land cover app. And what we're asking you to do there is just the first steps. So the first, and you know how to use it already because the app has been designed so it's the same in both places. So here you've got your location, you describe the surface, and this data is very useful for scientists that are looking at images of or spectral data to make sure that we're not mixing up snow and ice with reflecting standing water with a cloud, for instance. So that's why that's really important. And then this is the step that is really necessary, and we hope that you will do for our data challenge. We want you to take pictures up and down, north, out, south, east, and west. And so this is hard to believe when it's like 100 degrees here, but just 2 months ago, I took these pictures from my front yard, just for this thing here. But you turn it on and there's actually a compass built into your phone, and most phones are able to get this. So all you do is you just line up your photo with the north, south, east, and west arrow, and it either takes automatically or you tap the picture and it takes a photograph. Take a picture up, take a picture down. You just line up that circle until it's exactly right, and then you take the picture. All right. So there's another step that you can take, and that is analyzing the cover, where you might, you'll take a picture and you'll look at it and you'll say, this is 80% grass and I see 20% canopy cover. So you can do that, but it's more time consuming. And so we really need the photos. So we're asking you that if you just have a little bit of time, go ahead and skip the analysis, save the photos, because we are getting AI. Artificial intelligence is now being developed by 5 different projects, 1 from National Science Foundation and 4 paid for by grants with NASA through the EPSCoR program. And they are developing the AI that's going to be used to categorize our mosquito habitats, our larvae, and our land cover photos. So that's why I'm really pushing this importance of these photos. Then, of course, you can see there's all kinds of wonderful things in the app we can't show you, but you can look at all the measurements from a single day on the app. You can look at all your observations and so on and so forth. So what I would like to do is just take a minute here for people, and I just mean 5 minutes, because this is a very short presentation that we're doing, but it's 12:12 now. I would like to come back at let's say 12:20, and I'd like you to go out and use your land cover app to make a measurement. I'd like you just to step out from where you are and look up, look down, north, south, east, west, grab those photos, and then save them and don't do the analysis. And so I thought I would take a break here. And so for those of you who can do that and have not done this before and would like to, please do so. I'm not doing mosquitoes because I don't expect everybody to have mosquito place right out of their door, right? But land cover, it's wonderful. It's always there. So go ahead and do that. And then I'm going to go into the chat, and I'll be answering chat questions for the next 8 minutes. And then we'll come back and I will finish by talking about this incredible experience that we're going to have helping these science teams from all over the US who are working on AI using our data. Okay. So I'm going to stop my share right now, and please come back in about 8 minutes. And if you have already used the app and you don't feel like you want to go and do this, we can chat. I can take some questions. You can raise your hand. We'll take some questions. You can put questions in the chat. And I just like to make this just a little bit more interactive. So, okay. So does anybody have any questions so far? And if people, I'm really hoping people have gone outside, but if you haven't gone outside, please tell me who you are and your experience with either mosquitoes, land cover, or the surface temperature protocols. I see these names, and many of them I recognize. Many of you are very experienced with Globe. And so it's just a delight, and I'm very honored that you came to hear about what we're doing today. So Sherry says that she's thrilled about the AI. Hey, we are thrilled too. We are so excited. And James Harrington, who is running the EPSCoR program at NASA Goddard, they started something called the AI Center of Excellence the Goddard's AI Center of Excellence. They put out a request for proposals this spring, and they identified 4 or 5 spots for people who wanted to work with Globe Observer data and develop AI. And so there are, in fact, 5 different teams that have been funded, 4 of them through NASA. One of them is at the University of Vermont. One is at the University of Wyoming. One is at the State University of New Mexico, and one is at the University of Puerto Rico. And these teams are all doing the same thing, but using different, different scripts, different languages, different ways of developing AI. So it's kind of like a really exciting research lab scattered around the country. And there's also going to be hackathons that potentially we can get our students involved in, depending on what the parameters are for the, for the work. The work is going to start happening either this September or in December. And so that's exactly why we are doing this photo campaign now. We want to get several thousand photos that we don't have already to support these scientists in this work. Mr. Salisbury, have we been having problems with the bandwidth this morning?
Yes, we did from some of the remote places, but I haven't seen anything from either of on this presentation at all, cutting out, or everything also looks very clean as far as the screen sharing.
That's really good. And I thought that it might help if Rick and I kept our photos, our video, our personal videos off, because I think that does make a difference. So
yeah, I do too.
Yeah, great.
Good safety.
Good. Okay, so we're going to start up again in another couple minutes, but if anybody has any questions, I would be thrilled to answer them, either about the surface temperature, which I am not a master trainer on, but the mosquitoes and the land cover, which I am. And I would love to entertain any questions or ideas that you might have to engage your students in doing research using these protocols. That's very exciting too. And also, when Rick was giving his presentation, because I knew that he wasn't going to be here to support the chat when I was here, I just took the time to put some of the important URLs that we present in this presentation so that you can grab those off of the chat if you want, and have those in your library so that you have everything you need to do programming. Ilias, thank you so much. I hope that we have time to connect with each other again soon. It's great to see your face here. And yeah, it's probably not good where you are. And I kind of forgot about that, the world goes dark half the time. So yeah, that was my bad. So thank you for being understanding. The other thing about the land cover app, which is different than the mosquito app, is that there is a very short tutorial you have to do in order to take pictures. And there's a longer tutorial you need to do if you want to actually do the classification so that you come up with the muck classes. So to do the short tutorials so that you can take the pictures, it's very fast. You can do the tutorial in a minute or two, take the pictures in 5 minutes, and then you're done. So it's a really, really handy and really nice opportunity. There's also another very nice module in there that teaches just a little bit about satellite data that can be used as a jumping off point for students that are interested in using this data in the understanding and examination of satellite data that they get from NASA's remotely sensing what do I want to say, instruments that are on their platforms up in space. Okay, well, it's just about time to get started again. So I'm going to get my, can you guys still see my screen? Can someone tell me?
No, not right now for me.
Not, you can't. Okay, I'm going to just start it over then. I thought that would be the case. So I'm going to start my slideshow again. Okay, can you see it now?
No, I'm not getting it.
You're not getting it. Okay, all right. So share screen. Here it is. Let's see if that works.
Ah.
Is that good?
Yep.
Okay, good. All right, fantastic. Okay, so we are back. And what I wanted to do now in the last 10 minutes, like I said, please put any questions you have in the chat. But what I wanted to do is give you an opportunity to learn a little bit more about the Mosquito Habitat Photo Challenge. It's going to start in just a couple weeks. It runs for 1 month from 25 July to 25 August. And like I said earlier, we have these 5 teams that have been funded by NASA to look at the photos that globe observers are collecting and develop artificial intelligence routines to do automated classification. So, right now you can use the app and you can say, this is an Anopheles mosquito, right? But we need to also verify your classification. And so we will also have eventually an AI, an artificial intelligence classification system that will say, we believe that this is Anopheles, yes, no. And then you'll be able to say, yes, that's what I think. So it's going to be a phenomenal thing that we'll have in a couple of years in this app. The same thing is true for our vegetation classification and for our water source classification for the land cover and also for the mosquito habitats. So this is why we need those photos. We need thousands and thousands of photos. So please take lots of pictures. Okay. So I just said we have this money from NSF to do this, and it's going to be very, very exciting. I just wanted to let you know that if you decide to grab this slide set and use it for your own, it's always good to tell people about safety. Make sure that even though the larvae have they can't transmit any of these diseases, they do not pose a health hazard, but you may want to cover yourself, use insect repellent, and also maybe wearing dark colors. These are the things that you need to do to improve safety. And also, this is very important too, that in many parts of the world, including where I live here in Colorado, we're having another outbreak again of COVID-19, and you want to follow your local health official guidance as to whether or not it's safe to go outside and do these kinds of procedures. Tends to be a little bit safer to do globe things outside when you're not in an urban area. Okay. All right, so what do you need to participate? You've got the app on the smartphone. You're going to want to get a clip-on magnifier that you can get from your online on your online stores. We suggest a 60 power magnifier or better. And then there are some supplies here that we have listed on the right-hand side. They're pretty simple: paper plates, paper towels, some toothpicks, some plastic bags, a cup or a turkey baster to obtain your sample. And then you go and you find your habitats. And then, and we have these new photo tips that we've developed specifically for this challenge. And you can find them in the Partner Google folder, which I have given you access to. Basically, it just shows you how to attach the clip-on magnifier to your phone. And then we ask you to take lots of pictures. The Globe Observer is asking you to please take 1 picture of the body and then to take 1 picture of the tail end. But for this challenge, because we need so many pictures, we are asking you, if you can add up to 9 pictures to your observation. So go ahead and take a picture of the full body and then move it around with a toothpick and roll it over, and or move it so you can see different hairs. Take another picture, take another picture, take up to 9 pictures. They need pictures of the full body, of the tail end, which includes the siphon, if it is a mosquito that has a siphon, as well as the end part, which has the saddle, the different hairs. And they also would like to have pictures of the head and the thorax, because even though we don't use the head and the thorax to identify the medically important species in our app, it's important to identify other species. So please go ahead, take as many pictures as you can. And so I'm going to show you now, and I put these links in the chat so you can get them, but you can see we've got some fantastic resources for you. And we have just a taking larval photos handout. We have a welcome to the challenge. We have a couple of these things that you can use to share with your community. Whoops, excuse me, let me get this down here. Okay, whoops, that didn't work either. Just trying to, there we go. And then if you've done any of the other Globe Observer challenges, one of the things that we developed during the pandemic, when people couldn't necessarily go outside, but we still wanted to do the challenge, we found out that this works great. We have a challenge activity tracker. So you can, yes, you can make an observation, take a land cover observation, take a mosquito observation. There are other resources, so you can take a nature journal, a class, a class or after school program could conduct a mosquito habitat survey. We have learning materials, we have engaging materials, we have some materials that allow people to be creative and use their artistic skills. So we have all these different things that are available, and they are in the links that I gave you. And they've been developed specifically for this photo challenge. So if you're not familiar with all these materials, please go to the website and you'll find them. So, oh, and I hate this picture, but we've got also some little videos where, the video will show you how to build a larva trap, how to actually identify the mosquitoes. We have all these things. Inez Maud is on this call. This is something that one of her students did, I believe in 2018, but she did a challenge where they made posters, which were, public service announcements. And this is from her school at Minas Gerais School in Rio de Janeiro. And one of her students made this public service announcement. So there's all kinds of things that students can do to build their understanding and their awareness about mosquitoes. So we have a video, we have data that you can explore that's already been, cleaned up a little bit and easier to use. You can read about mosquitoes in land cover. We have a disease guide. I hope all of you have seen the Zikazine, which is just a fabulous product done by my friend, Dr. Lisa Gardner. And it's actually available in 10 languages at your favorite Globe website. There's a video where you can actually, she talks through this wonderful Zikazine that she has done. And we also have videos that you can take a look at. And so we have all those linked in these resources. So here is the Mosquito Habitat Photo Challenge. You know now that there is this wonderful activity tracker that you can use. We hope you'll go out with your classes and with your students and with your family and take as many photos as you can and be part of cutting edge NASA science as they begin to do AI. And I promise you that this will not be the only time that you connect with this project, because we will be connecting with you as we begin to develop the hackathons. And some of the hackathons are going to be remotely online. So you can participate and get your kids involved in learning more, a little bit about data science. So this is a cool way to get people involved in that whole cycle, the whole data cycle. Okay, we're almost done here. We just got a couple more minutes, but I just wanted to show you, we have some fabulous resources been developing over the year since COVID. We have a mosquito science notebook that has all kinds of different resources that help people to understand and learn about what's a mosquito and what's not, where you find mosquitoes. We have something we just developed just in time for this this challenge. It's the Mosquito Larvae Hunters Level 2 training, and it actually steps, it's designed for students, but it steps them through every step of using the app and identifying mosquitoes, and it's really pretty cool. So those are the resources. Here's
We
some
do have a
people.
question in chat for you, Rusty.
Okay, I can't see the chat. Can you read it to me, please?
Is the challenge activity tracker available in French? And if it's not, she's willing to translate for us.
Okay, would you put your email in the chat, please, and I will reach out to you. We don't have it. We only have it in Spanish, English, and Chinese. So it would be great to have it in French. So please contact me, and I would love to work with you on that. Thank you so much. Thank you so much for that. Okay. So anyway, these are the links that I have already put in the chat for you. But here's the important thing, and oh, good, we're right at time, but here, we do have some mosquito kits that we are giving away to teachers or Globe classrooms that would like to have a few clip-on microscopes in a bag. And we are giving these away. You need to let us know, I believe, by the 14th of July. So you've got 2 or 3, I guess 3 days to let us, 2 days to let us know, but use this Google form and apply to get one of the kits. So that is the end of my presentation. We tried to cover an awful lot. We wanted to really connect mosquitoes and land cover to surface temperature, give you some ideas for how you can use these protocols in your classroom research settings. And most importantly, please get the word out about this data campaign. We don't want to have egg on our face saying, oh yeah, Globe observers are all over the world. We can get these photos for you, and then not be able to have enough photos. So we really hope that you'll enjoy it. You'll enjoy this, and you'll enjoy the challenge with us. So thank you so much for your attention today. And I'm sorry that Rick had to take off, but if there's any questions, I'm right here. And thank you very much. Ilias, I'm going to be contacting you. Thank you so much again. Lynn, I'm sorry, I see your hand.
Yeah, I didn't think to look for those.
Yeah, I see her hand. She may have already signed off.
Yeah, she should disappear then.
Oh yeah, yeah. But I would love to answer your question, Lynn, if you can. You need to unmute, please. Yeah, can you unmute him, David?
Oh, that's right.
I'm sorry.
That's right. I got to do that.
Yeah, David's got to do that.
That should do it.
Hey,
Hi, nice to see you, Lynn. It's been a long time.
I know. I am the president of the Northwest Arkansas chapter of Master Naturalists.
Oh, wonderful. Mhm.
And I would really like to have some of those small microscopes to give to, we've got 350 members in our chapter. I'm not talking about that many, but we just have a large chapter and they're very active and they like getting out and doing things. And so where is the link?
So the link, I put the link in the chat.
I'm not seeing it.
Let me see here. Let me find it for you.
Video library one. Let's see.
I see the student research projects, but I don't see the,
Let me just do that again for you, just in case.
okay.
Here it is. Okay, everyone, there it is. Yeah, so it's up there. It's a bit.ly for Mosquito Partner, and you got you got 2 days. Lynn, just tell them that you are a Globe Master Trainer and you're working with this group and you need to have the microscopes. And I think I think it's a small number. I think it's 5, but it gets people going.
Yeah.
You know, and they are very inexpensive. You can get them for about $6.
Do you know
Um,
where, do you know where?
I do. You can go to, and this is not a global endorsement, but I go to Amazon, and
Amazon.
yeah, and I look for 60x clip-on microscope cell phone. And there
Like
are,
these things?
yeah, yep, and there are many, many
That's-
different brands and different things. Just get the cheapest one
Okay,
because they're all the same, but they are listed by different people. They go up to $20, but they're exactly the same as the ones for $5. So good luck with that.
okay. When it says option 1, what does that mean on the form?
On what form?
I'm looking at the form for mosquito larvae and it says option 1. I don't know what that means.
Let me take a look real quick and let's see if I can find that for you. Okay. I don't know what option 1 is.
It may be an extra question that got put in there by mistake. I've made a lot of these
Oh,
forms.
yeah. It's probably yeah, it probably is. I would just check option 1, why not? And then and it says, how will you use the Globe Challenge in your summer program? Just
Yeah.
say, just tell them, master trainer, been with Globe since day one. I'm working with these master naturalists, and they're going to be really excited to get these data for us. So, yeah.
Yep, okay.
Thank you so much. I'm glad I saw you. It's good. It'd be great to have you participating and having some really enthusiastic people taking pictures of the world around them, and especially land cover. It
Yeah,
sounds like that'd be
it's,
something.
it's funny because when Melissa was first doing this mosquito thing, I said, this should be a protocol. And people went, oh, no, because we have too many protocols already. And I went, no, this is pertinent all over the world. It should be, so I'm at least glad that even when nobody paid attention to me, somebody paid attention to somebody.
No, you were prescient, Lynn. That was wonderful. And you're absolutely right. And we've gotten a lot of traction.
Yeah.
CDC is interested in this. I gave a talk to the CDC in Ethiopia. I mean, it really is something where we can really make a difference. So thank you.
And I knew that from the very beginning when Melissa was just doing it as a learning activity. And I'm so glad that it has gone beyond that. So anyway, I'll sign off.
Thank you very much. Take good care,
Bye-bye.
and
Thank
great
you.
to talk to you. Bye-bye.
And I'm doing a K4 section if you're interested in any of the materials. So
I hope so. I'm trying to get as many as I can. Thank you.
bye-bye.
Yeah.
Well, I guess I'll end the session. I don't want to be bumping into somebody else's Zoom meeting.
Okay, great. Thank you so much, David, for your careful and excellent monitoring today. Hello, Elena. It's good to see you.
Bye-bye.
Bye-bye.